Hello, my name is James Lechinger, and this is a demo of my final project for EEC 172. So my project is a 3D printing warning and auto abort system. So I have 5 different things going on. I have 3 commands, so I can tell my printer to remotely pause the print, resume it, or abort it. And then I also have a auto shut off, auto abort if the temperature gets too hot. And then I also have a edge detection system that will detect when a print is failing and will send you a text message. So the first part of my project is the commands. So here you can see on my text message, I'm in like my SMS text message app on my phone. So if I type in pause and I send the text message, you should be able to see after a few seconds it says pausing for my 3D printer. And then if you look at the 3D printer, before it was printing a boat and now it's paused the boat. And if you look at my text message, it says print paused. So now I'm going to type in resume on my phone. Type in resume and you can see that the 3D printer just started resuming, and I got another text message saying print resumed. And then if we go back to my 3D printer web server, you can see that it's now printing again. So the third command, so I did pause and resume, the third command is abort, and this will completely cancel the print. So if I type in abort, so I typed in the command, and now it says print aborted due to user action. Okay, and now you see the print has completely stopped. And if you look at the state on my 3D printer's web server, you can see it says operational. That means it's no longer printing and it's ready for a new print. Okay, so now I'm going to showcase the auto abort feature. So here we can see the printer is printing, and in a normal situation it should just continue printing normally without any errors. However, sometimes 3D printers can catch fire, and so I've created an auto abort system if the temperature reaches too high. So normally it will auto abort once the temperature reaches 160 degrees, but for this demo I'll just abort it once the temperature reaches 40 degrees. So I'll simply start it by restarting my microcontroller, the CC3200. Okay, so now it should be registering the temperatures now. So you can see on the Raspberry Pi, it's detecting temperatures obviously above 40 degrees. Okay, and now it says command temperature abort, aborting printer due to excessive heat, and you can see that the printer has now aborted. And also on my phone, you can see that it says print aborted due to excessive heat. So if I'm out and about, I'll get a message and I'll know that my print has stopped. Okay, so the last feature that I'm going to showcase is error detection, or print detection for a bad print. So you can see here that this print has failed, and when prints fail, the printer starts printing on nothing and it creates these long strings, which obviously have many edges. So I created a edge detection script in Python that runs off this camera. So when I place this failed print in here, it should detect the failed print. And so you can see I'm actually connected to my Raspberry Pi, and you just see it says print failed, characters detected on receive channel. So, and here's a picture of the Python script that's running edge detection, and you can see everything that's white is an edge, and you can see that all those strings create many edges. So if you look here on my phone, I just got a text message, so now it says print failed. That was the latest one. And so now if I'm out and about and my print fails, I'll know about it, and then I can send a command to the printer to tell it to abort if I want it to abort. Or if it was a false positive, I can just do nothing and it'll continue printing. Okay, so now we're in a park that's about a mile away from the 3D printer. So I'm going to show off like kind of the remote capabilities and kind of the purpose for this project. So the idea is that you can kind of control your 3D printer from anywhere. So now that we're like a mile away, I'm going to try doing the same commands I did earlier, and we'll see if it worked. So here's the text message, the SMS. So I'll send a pause to Amazon Web Services, and we'll see what happens. Okay, you see, so it actually paused. It paused the printer, and it responded saying, "Print pause." So let's try resume. And you can see the print did resume. Okay, so here's a walkthrough of my project setup. So on the left side of the printer, I have my CC3200. It's connected to power via this USB. So this USB just goes to a USB adapter wall outlet. And then there's 3 cables that are connected to the Raspberry Pi. This first cable is just a common ground. And then these 2 cables here are TX and RX for UART serial communication. You can see that the white on one side goes to the black on the other side, and the vice versa for the black cables, and that's because you want to connect the transmit of one side to the receive of the other. I tried doing the UART communication through the USB cable, but unfortunately the Raspberry Pi's USB outlets right here, they just don't have enough power to power the CC3200, so I had to power it using the wall outlet. Then there's an iPhone XR right here, and that's just running a Wi-Fi hotspot that the CC3200 is connected to. I could connect the CC3200 to like the home Wi-Fi network, but unfortunately the signal is just not strong enough, and so it disconnects. So I have it just connected to this Wi-Fi hotspot right here. And then the Raspberry Pi is connected to the camera via this ribbon cable, and then it's connected to the 3D printer via this USB cable, and that's just for UART communication between the Raspberry Pi and the 3D printer. And you notice that the camera and the Raspberry Pi case are both 3D printed. Okay, so here's my laptop, and you can see that this is actually running the operating system for the Raspberry Pi called Raspbian. I'm connected to the Raspberry Pi through a VNC, remote desktop server, and so I can actually fully control the Raspberry Pi and see what it's sending back. So right here you can see this is the info from the CC3200 that's sent to the Raspberry Pi through UART communication, and you can see it's connected to the access point called Hello. And that's simply the name of the Wi-Fi hotspot that the CC3200 is connected to. And then you can see farther below it's actually connected to the Amazon AWS servers. Okay, so I'm going to exit out of the VNC server on my laptop, and I'm going to go over to Octoprint. So this is the web server that my 3D printer is using. Okay, so now I'm going to go over my code. So I'll start with the code on the CC3200. So I started with the UART demo project and added onto it. So here I've added to the global variables. Rec buff is the receiving buffer from HTTP GET. I have this as a global array because HTTP GET is its own function, but I actually need to access the data in the main function. So in order to make that accessible, I put it into a global array. HTTP socket is the socket that's used for the HTTP gets and posts. And since that needs to be shared between those functions, that's also a global variable. And then this is for the temperature sensor. It actually gets initialized in its own function, and so that needs to be a global variable as well. Okay, farther down the code, so this code is called when there's an interrupt when the Wi-Fi is disconnected. So this function is called the simple link WLAN event handler. And so in case that the Wi-Fi is disconnected, I want to know about it. And so what I did is that I added in some code to reconnect to the Wi-Fi, and then to send an HTTP post to my phone via SMS to let me know that it was disconnected from Wi-Fi. And ideally, you would have it reconnect the Wi-Fi and then continue with the code as normal. But unfortunately, I wasn't able to make that work. It's pretty complex stuff and pretty confusing, and I tried a lot of debugging, but I just wasn't able to get it to continue running code after it disconnected and reconnected to Wi-Fi. So I figured this was the second best thing, was just to send you a warning that the code basically stopped, so you can go and reset it. Okay, so now we'll go to the main function. So it starts by initializing the board and UART, and then down here it initializes I2C, and that's what I'm using to communicate with the temperature sensor. And then we connect to Wi-Fi here, and then we connect to the AWS server here. Farther down, so this is the main while loop where all the real stuff happens. So this here detects if any information was sent from the Raspberry Pi to the CC3200 via UART. And if this is the case, it means that there was an error. Normally, the reading and writes to UART are handled farther down the loop, so if something's written here, it means that something went wrong. And so I'll write an HTTP post to the SMS saying that the print failed. Right now, the only thing I have coming back from the Raspberry Pi to the CC3200 is the print failure detection, and so that's the only message that needs to get sent here. The other things will get sent from the Raspberry Pi to the CC3200, but they're handled farther down below. Okay, so here's HTTP GET, where I get the information from the Amazon Web Service from the shadow, and then I copy it. I copy the new command to the old command from the previous loop, and that's because I want to detect if there's a change in command. I'm constantly getting HTTP GETs from AWS, just to, in case there's an update, and if that update occurs, I need to be able to detect it, and so I store the current command and the previous command so I can detect the change. Here I'm finding the message in the entire GET message, so I'm looking for this command key within the entire buffer that I'm receiving, and so this key is equal to lambda, and the reason for that is because I'm getting the commands from the AWS lambda function, which then posts it to the shadow under the variable called lambda, and so lambda is the variable that I want to read. So I find it in the function using the str command, and then once I do that, I extract it into its own array, and then here I read the temperature from the CC3200, and then I change it by a constant. What I've noticed is that the CC3200 board heats up a lot when it runs for a long time, and the temperature sensor becomes very inaccurate, and so I ran the CC3200 for a very long time. I measured the temperature, and I counted for the offset here. So once the CC3200 fully runs for a while, then it should be recording about the right temperature. So if the temperature goes above 160 degrees, that means there's probably a fire. And so it'll send a warning message, and if this temperature is sustained for 20 loops, then it means definitely something has gone wrong, and it will shut off the printer by writing tempabort to the command variable. And so tempabort, we can see here, is just this string, and the Raspberry Pi will detect this string and know to shut off the printer. Okay, and if it's the first loop, then there shouldn't be any change in the command read, so this just sets them to be equal. Okay, so finally, this is the most important part of the code. This is what happens when a change in the command is detected. So this means a new command has been sent. So it'll send this command through UART using the UART print command, and then save it to the old command. And then it reads the response from the Raspberry Pi. So as I was saying earlier, if it read a response higher up in the code, it means something's wrong. When it reads a response here, this is just standard. The Raspberry Pi should be responding with something here. And so based off that response, I will then send an SMS message to my phone. So this is, I wait until I get to this point to send an SMS message to my phone, because this way I know for sure that the action was completed on the 3D printer, because this is the return message from the Raspberry Pi after it runs the command. Okay, and then here's HTTP post and then the HTTP get functions. I just changed a little bit with these. They're pretty standard. The reason I need both is that posting is for sending information to the shadow, and the get function is to get information from the shadow to detect if there's an update. So that's my code that runs on the CC3200. Okay, so now I'm going to walk through the code I wrote for my Raspberry Pi. So I wrote this code in Python, and I used the Thonny IDE, and this is running on the Raspbian operating system, which is a derivative of Debian. Okay, so I didn't write all this code myself. I'd say it's probably 50-50, and here are the sources for the rest. It was dealing with a lot of stuff that I've never really dealt before, so I definitely had to research a lot for this code. Okay, so I have to get the video from the web server of Octoprint, and the reason for this is you can actually only one application can use the Raspberry Pi camera at a time. Since I'm running Octoprint on the 3D printer and on the Raspberry Pi, this means I can't use any other applications on the camera. So the only way for me to do edge detection using the camera is to take the stream from Octoprint, import it, and then use it from there. And so that's what this is doing. The 192.168.86.29 is the URL for Octoprint, and then here the webcam this is the URL for the actual Octoprint webcam. And it streams live video at a resolution of 480 by 640. So it reads the frame one by one, and then here we initialize UART. So this is going to the CC3200 through those TX and RX cables, the white and black wires. Okay, and I made a log, and the reason for this is because I wanted to know during a 3D print how many edges are detected periodically, and that way I could set my threshold for what's a failed print and what isn't. Okay, I have a loop delay here. This is actually very important because this Raspberry Pi is running both this Python code and Octoprint, and if either of those services is using all the resources on the Raspberry Pi, the other service won't work correctly. And so if I basically am constantly using all the time on the Raspberry Pi processor for this Python script, Octoprint will get choked out and it will result in print failures. All right, further down the code, so this is the image after it's been decoded from the live stream. And so the first thing I do is convert it to grayscale, and then I use this function, which is part of OpenCV, to detect the edges. And you'll also notice, okay, so what I do here is I'm actually cropping the image. So as I said earlier, the original resolution is 480 by 640, and I'm only getting between 190 and 410 on the first axis, and then on the second axis I'm getting, or the second dimension, I'm getting between 20 and 620. And the reason for this is because I don't want the background of the camera. I only want the part of the camera that's focused on the build plate, and that will reduce the amount of edges that are detected in the background, which are undesirable. Okay, so here's the edge detection part of my code. So if there's no edges, then this won't run, obviously, because there's nothing to do. But if there are edges, then first it will find the number of edges, and it does this. So all these images are actually arrays in NumPy. They're called ND arrays, and so these are functions I'm running on these arrays. So right here I'm finding like the number of non-zero data points, and then putting that in an array, and then finding the size of the array. So that will tell me the number of edges. And so I said down here, if the number of edges are over the max recorded edges, then I have like a new max edges. So this is the max edges is like the maximum edges that have been detected throughout the entire print. and then I'll just print this out every 10 loops. Okay, so if log counter is over 1,000, I record a new log entry. So I just open this file and I write to it the number of edges and the maximum edge number that's been detected so far in a single frame. Okay, so if there's too many edges, that means the print has failed. So if it's above 10,000, so this is just kind of an arbitrary number that I thought was about the right value for my testing, then I will add a value to the edge counter, which basically counts the number of times that there's like more than 10,000, a frame has been recorded that has more than 10,000 edges. And once that happens 20 times, then we can say with pretty good certainty that the print has failed. And so I will write to UART that the print has failed, and the CC3200 will receive this message and relay that to the user. I won't abort the print because a failed print isn't inherently dangerous and there can be false positives, so I think it's best to leave it up to the user whether they want to abort the print or not, but at least this way they'll be notified. Okay, this just shows each frame on the screen. Okay, down here, so now I'm receiving serial data from the CC3200 if any has been sent. And so I'll read the line and I'll strip all the white space from it. So if there's a command, basically if it's reading the UART actively, and if it sees this string, it knows that there's a command. And so after it knows that there's a command, it will take the data directly after that and store that in the command variable. And if it's any of these specific commands, then it will do these actions. You'll notice that it's command.lower. This means it takes all the capitalized letters and puts them in lowercase. So no matter how many capital letters you put in the command, it will still recognize it. And this actually is running shell commands. It's interfacing with this program I installed that provides kind of a command line interface so I can interact with Octoprint through the command line. And so these are just running shell commands. And then after I run the command, then I write back to the CC3200 that the command has been executed. And then down here, so along with commands, the CC3200 might also send messages. These are low priority and I've just been using them for debugging, but it will print it out to the terminal just so I can see what the CC3200 is doing and what messages it's sending. Oh, and then this none command is just if after I write a command, I need to reset it. So I always just reset it to none. All right, so we can run this code and see what happens. And so I've placed a 3D printed toy boat on the build plate so you can see what objects look like with just their edges. And you can see there's actually not too many edges on this toy boat. Even though it's a pretty complex part, there's still very large pieces that have no edges on it. And that's good because that means that it won't be detected as a failed print. And you can see down here, it only detects it as 6,000 edges. So even this complex boat's only 6,000 edges, and so hopefully we don't have too many false positives since the bar has been set at 10,000. And then, so earlier I ran the code with my CC3200. Right now I'm just running it by itself. So I'm going to show you some of the commands that were registered earlier. Okay, so you see that everything that the CC3200 prints to UART actually shows up in the terminal on the Raspberry Pi. And that's because it's being sent through UART and then it's being printed out in this terminal. So you can see all the things that are going on. If I scroll up a little bit more, you can see some of the commands I've sent. So for example, I sent the abort command. So it registers the command as abort, and then it actually aborts the printer. And you can see if the printer's already been aborted, it will send this error message, but the actual Python code won't crash. It will continue running. So if you accidentally type abort twice on your phone, it's okay. The program won't crash. And you can see here's the pause being registered, and it's pausing the printer and resume. So yeah, there's my code running in Python. So here's the log file that my Python script has created. each time it runs, it will, instead of writing over the previous entries, it will simply make new entries. It will append to the end of the file. And you can see, so this very long string is a full print that I executed for the toy boat. And you can see every 1,000 loops, it will say how many edges that specific frame had. And you can see it never really comes close to the 10,000 threshold. And even the maximum edges that's been recorded over on the frame that was like the worst case scenario still doesn't reach 10,000. But even if it did reach 10,000, it would be okay as long as it wasn't sustained at 10,000. As long as the next few were under 10,000, it's okay. I only get the warning message saying that the print has failed once it's over 10,000 for 20 loops straight. Okay, so now I'm going to go over the code that I wrote in AWS. So here's the Lambda service. So this is code that is executed remotely in the cloud. And so here's the Lambda function that I wrote. And I didn't write all of it. I did do some research for this as well, and use some of that code. So those are my sources. But basically what I'm doing is very simple. I'm retrieving the information from the SMS messages that are then forwarded to this function through AWS Pinpoint, and then I'm converting them into a format where I can update the device shadow for the CC3200. So it's very short. Just the beginning of this, so the message is pretty lengthy, and so I'm just trying to find the message body. That's the important part of the message. So I used a find function that's part of Python. It's a very helpful function. It finds where this message body string occurs in the overall message, and then from there it will detect the message that's supposed to be sent to the device shadow to update it. It puts it into like a JSON format, and then sends it over to the client. So here you can see this is the JSON format that it's being put in, and you can see it's changing the Lambda variable, and that's the variable where all the commands are going to be saved. And then down here, this is the most important line of the code. This is where it updates the CC3200 device shadow. So if I modify the code, or if I send a command, so I'm opening up my phone right now, and I'm gonna send the command. I'm just gonna send test, which isn't an actual command. It's just for demonstration purposes. You can see the Lambda function will update. See right there? So now instead of saying none, now it says test. And AWS also has this service called CloudWatch. It's kind of like a log service. So you can see it's 5:02 p.m. right now. Well, maybe you can't see that, but anyway, it's 5:02 p.m. right now. And so there should be a new log file there. So this code, you can see it ran at 5:02 p.m. And if we see, here we go. So we see the name of the command, it's test. And we can see this is the full payload from SNS, and it will update the shadow with the test command. Okay, so now I'm going to go through a block diagram of my project and wrap it up. So here you can see that these are all the elements of the project. So I'll go through each of the functions of it, and you can see how it kind of interacts with the different blocks. So first, if you're sending a command to the printer, so you start with an SMS phone, it gets sent to AWS Pinpoint, which relays it to AWS Lambda. That will extract the command and put it in a format so it can interact with the AWS shadow. When that updates, it will be received through the CC3200 through Wi-Fi. It will use an HTTP GET to get the shadow. Once that shadow, once that command is on the CC3200, it will send it to the Raspberry Pi via GPIO UART, which will then be sent via a shell command to OctoControl, which will then send the command via HTTPS to the Octoprint server, and the Octoprint server will then send it over UART on the Raspberry Pi to the 3D printer, since the server is running on the Raspberry Pi. Okay, and now if, let's say, there's a auto abort due to excessive temperature, it will start at the temperature sensor, which will communicate with the CC3200 via I2C, and then that will be sent both to the AWS Shadow and GPIO UART, so that shutdown command, the abort command, will be sent to the Raspberry Pi, again to OctoControl, to the server, and then to the 3D printer. Meanwhile, a notification will be sent to the AWS Shadow, which will then be sent to the SMS phone via an MQTT topic. Okay, and then finally, if there's a print failure due to like stringing, that will be detected on the Raspberry Pi 4 with edge detection code that it got from the live video feed that's hosted on the Octoprint server, and then it will send that over to the CC3200, which will send it to the Shadow, and again to the SMS phone via the MQTT topic. So now I just want to go over a few different things that I wanted to talk about. So I pretty much accomplished all the things I wanted to with this project. I was able to remote control the 3D printer via SMS. I was able to do all the commands I wanted to, which is pause, resume, and abort. I was able to detect a print failure via stringing through edge detection, and I was able to send warnings out based off that. And also I was able to implement fire detection using a temperature sensor and the auto abort system. If I had more time to work on this project, I want to get the Wi-Fi more reliable. At this point, it's fairly reliable through a hotspot, but I would like it so that you could use it with a home network, so you don't have to use a hotspot. I would like more remote control commands. I think that would be helpful if like you could start a print with like a certain predefined file. It'd be nice if you could like on the fly change some of the temperatures and speeds. For example, if the print seems to be kind of low quality, maybe you could change the speed to make it faster, or to make it slower. Or like if you're going to be home soon, you want the print to be done, you can maybe speed it up. That would be cool. I would also like to add more warnings and informational messages. For example, maybe every like 30 minutes it would just send you a message just with the temperature reading from the CC3200, or it could like send you the printer status, whether it's operational or not, if you're like wondering if you want to start a print or not. I'd also like to put the 3D printer in an enclosure to reduce the number of like background edges that are detected. I'll be moving soon, so it doesn't make a lot of sense to buy an enclosure now, but maybe once I move, I'll put the 3D printer in an enclosure. But overall, I accomplished what I wanted to with this project, which is basically to make 3D printing more easily controllable from on the go, and then also for it to be safer. So overall, I think the project was a success.